Okay. Now, in fact, it's obvious that authority hubs analysis we did is just a variation of the degree. It is really a transitive closure on the authority is a transitive closure on the in degree, okay, and hub is a transitive closure on the out degree. That's what it is. Yes.
In social network, how can you describe that? That is how that is secured. Because social network, if I have a profile and if I have
no, what social network is.
How can the network decide that they come to me or I go to them?
Again, as I said, if it's a directed network, then you have authorities and hubs. If you have undirected networks, then you don't. Okay, so even in social networks. So, for example, I know Obama, and don't laugh. Okay, I think he probably knows me too, but I certainly know him. So, in this case, I have a big link to him. He doesn't have a link to me yet. Okay, so it's a social network. I'm in his social network. I can quote him once in a while, but he may not know me. So that's why in this case, I guess you can have social network with directed edges.
So you are saying that you are going there. So he also comes to your side because he also have a path to you.
No, in this particular case, I don't think he has. I mean, unless I checked and my page rank has really improved. We do kind of look similar, we are brown, but other than that, I think we sort of end.
You are saying that your friend goes to the Obama. You are saying that link.
No, I can see, look, there is no single definition of social network. I can, for example, define a social network which is only just I know, where no is a unidirectional, not a bidirectional. Normally when we say I know somebody, that means they also know you. Okay, I'm friends with them somehow. But we also say I know Obama. That doesn't mean that that's a symmetric relation. And hubs and authorities are defined for directed edges. Okay? Okay, so that's one type. You are sort of interested in, you probably are not surprised that that's one way of measuring importance. This is the other type of importance, closeness centrality, which basically means who in US is equidistant, closest to everybody else in terms of their friendship. These people may not be the most important people, they are not the most unloved people, but they just happen to know everybody. So for example, if you are in high school and you have the athletes here and the brainiacs here and they glare at each other, and there is this one person who seems to be friends with all of them. So of course, this is the person who probably gets beaten up most, but the point is, this person is more central to the high school because they are connecting these two clusters. Okay, and if in fact the high school is going on a, normally you would say who is like the most popular student in the high school, and normally that's like the math club president, right? So you would just go. I'm sorry, I'm hoping that you would just go and talk to that person. Okay, but what you find sometimes, let's say there's a huge fight brewing between two different communities in the high school. Who is the person who could potentially stop it? The one who knows everybody. So it's this one person who is neither an athlete nor a math club person who happens to know both of them is the guy you would go to. Okay, so sometimes centrality makes more is important. It depends on what's your problem. Okay. And the centrality can be defined in terms of closeness centrality, which is who are, of all the nodes, which are, for each node you consider the geodesic distance to every other node in the web, in the graph, take the average of them and see which one has the lowest average. That would be the most central. Okay, the other one is betweenness centrality, which is, and basically how frequently is this node going to occur in a path from any two random nodes. These are correlated, but they are not one and the same. Okay? And so again, these are useful measures of a social network and of a node in the social network. Just like you can't tell whether authority is more important or hub is more important. And similarly, you can't say centrality is more important or authority is more important. Both are important. Okay. And then you also can talk about cliques in a social network, which is strongly connected components of the graph, subgraph of the social network which is fully connected. Okay. So we have done all our definitions for the social network. Now my question is, I want to talk about small worlds. So if I have a social network, what is the likelihood that given two random actors, two random vertices in that network, one can be reached from the other with a short path? Now what is a short path? If I have n nodes in the network, what's a long path? Long path is n or infinity. If you are not connected, it's infinity. But normally you think of path lengths in terms of only connected. If you're only connected, you would give the number. If not, you say you're disconnected. Okay? So longest is n, or of course infinity if you take into account unconnectedness. Shortest is 1. Or 0, in fact, if you're talking about yourself. I know myself. Okay? On the other hand, if we know ourselves, we don't need psychiatrists. But let's assume that we are just talking about normal friendship, so just 1. Okay? So a small, normally when I say small word, you think it's closer to the short than the long. And one way of thinking about it is the size of the average path in this network is of the order of log of n. If it's order of n, that means it's a network where people basically don't know each other. It's like, you know, they have to go through everybody to reach the final guy. Log n is pretty reasonable, right? You're talking about, you know, it's logarithmic in the size of the network. So any network where the path length between any two nodes is expected to be logarithmic in the size of the network, you would consider that as a small world network. So what we'll do today in the next, I guess, 6 minutes is talk about some cute games which actually talk about the ubiquity of small worldness in our own lives, because we keep, you know, spending our time thinking about it. And then next class, talk about under what conditions do random networks have small world phenomena. Okay, so small worlds. So this, I don't know if you remembered in the beginning of the slides, I said some of these slides were taken from Kentaro Toyama. This is the Kentaro. And this guy essentially used to work in Microsoft Research in Seattle with a guy called P. Anandan, who then went off to India to start Microsoft Research Bangalore. And Kentaro went off with him. Okay, so when he went to Bangalore, essentially he had not enough people that he knew. You know, when he went to the first gathering, he is a Japanese American, and so he went to Bangalore, and you know, he was trying to make friendships. And you know, the way you break ice is, you know, I know this person, you know that person, so they're all friends, so we should be friends, right? That's the usual thing. So he went to some party, presumably, and so he was trying to make sense of connections. So he said, you know, these are, you know, he found that Ranjit, he knows Ranjit through Bash, and this was through Microsoft connection. This is an ASHA, which is an organization. Kentaro also went to Yale. Sharad was in Yale. Sharad was in New York City, and Ranjit was in New York City. I guess presumably that's linked to thin a connection because New York City has about 14 million people. But you know, maybe they would be knowing each other. And then so pretty soon he realized he knows all these people in his social network. They know all those people. Okay, so if you start feeling happy, I'm sure you can write your own social network too and realize that you know people pretty much everywhere. And in fact, what's interesting is he pretty much found even before he went to, you know, in the first few days, that this guy is the, you know, president of India at the time he was in Bangalore. And it turns out that he has a nice little link, Anandan Balki president. So when I looked at his slides, I felt really sad because I was from India, I didn't know the president. But then I said, look, I know some people here, it turns out. So let me plug myself into his social network, which is exactly what you do, right? You get into various cliques so that you expand into your social network. So if I throw myself into his network, I know Drew McDermott. Drew McDermott works in automated planning. You know, I like his work and he knows me. And you know, Kentaro knows him because of Yale, but I know Drew McDermott separately. I know Professor Junjunwala, who actually he taught me communications. I used to be electrical engineer at one point of time. Okay, so I know him quite well. And I know Balki because essentially Balki was in Indian Institute of Science when I went and did my sabbatical there. You know, he's the head of a center. Now, all of a sudden I realized that I know the president. I didn't know before that I knew. But Facebook knew this all along. You understand what I'm saying? one of the things about our normal lives is if you have to draw the social network yourself, you don't know who your friends' friends are. You don't know how far you are from anybody because you actually have to traverse the network. Whereas if I have this graph in front of you, which is what Facebook does, then they can say, yeah, of course Rao knows Kalam. I mean, you can go to President, of India and just say, I used to know Balki. Okay? And it turns out that actually the guy who taught me communications knows the Prime Minister, who is still the Prime Minister of India. This guy is no longer the President of India, but this guy is still the Prime Minister of India. Okay? And so I can go and talk to Ashok and say, put in a good word for me with Manmohan Singh. So you think I'm just sort of a loser teaching this course, but turns out I have lots of connections. Okay. Okay. So this is normal human network. And it turns out that I suddenly found what's more interesting is, other than the fact that I stole Kentaro Toyama's slides, it turns out that I'm actually only one link away from Kentaro. Because I know Drew, he knows Drew, so we can talk about Drew McDermott. So in fact, that's what I did, I think, when I stole his slides, saying, we know both of us know Drew, so we should have used the slides. Okay, if you're doing this, at a more global scale where everybody knows what the game is, this is the Kevin Bacon game that this guy was talking about, which for whatever reason people have decided that the most interesting thing to analyze in Hollywood is how close is any random Hollywood actor to Kevin Bacon. And the links are that you are connected to Kevin Bacon if you both took part in the same movie. Okay, you are both actors in the same movie. And then you and this person on a different movie together, then you are two connected. Okay, so the game of course is, if I were to give two names, Kevin Bacon and Amitabh Bachchan, which is like half of the class knows one name, half of the class knows the other name. And now we want to combine this so that we'll have a combined movement. It turns out that basically you have to look for movies in which Kevin Bacon acted with somebody else, who then acted with somebody else, who then finally acted with Amitabh Bachchan. Okay. Now what do you think is my Kevin Bacon distance? 0. Nobody yet asked me to play a role in movies. Okay. So my Kevin Bacon distance is 0. That's why we make the game interesting by only considering actual actors. This guy, he's also an actor in India. This guy is an actor here, and so it turns out that this is one particular path. Okay, it turns out Kevin Bacon was with Tim Robbins. Tim Robbins was with Om Puri. Om Puri was with Rani Mukherjee. Rani Mukherjee was with Amitabh Bachchan. So it's a small world after all. Okay. Now actually, it turns out that the game, it's a party game. You see, it looks like a party game. And people used to have these happy little party games in the old days when there is no web, so that now of course this is a useless party game because you take the thing and then go type it on the web and then get the answer. Whoever has the faster internet connection wins. So not surprisingly, actually there is a internet database which has the entire set of connections. Actors, you can use the IMDb database for example to figure this out. And then this Oracle of Bacon, which is at Virginia, will tell you, it's only claim to fame, and this is what undergraduate students do when they have too much time, is basically take any two actors and will tell you the shortest distance between them. Okay, and it turns out that according to that, actually Amitabh Bachchan has a Bacon number 3. Okay, I would leave it up to you to decide why Kentaro decided the long distance rather than the short distance. But what's more interesting about Kevin Bacon game is that there are about 550,000 actors in that particular thing. Okay, everybody thinks they're an actor. And the average path length to Kevin is 2.79, and the actor closest to the center, which is a universe about Kevin Bacon, turns out to be Rod Steiger. Okay, so Rod Steiger is the closest to the center, and Kevin Bacon is the 876th most central person in Hollywood. 876th most central person in Hollywood. Okay, so that's about Kevin Bacon. The thing that I want you to think of is not Kevin Bacon, but erdos. Just a second, sorry. Okay, erdos. This is erdos number is Kevin Bacon game for the brainiacs. Okay, so erdos is just as Kevin Bacon. Erdos is a mathematician, not just as. I mean, that guy is an actor. This guy is a mathematician. He wrote way too many papers. He's a very interesting, colorful character. He would just go with his suitcase, sit in one university, write papers with everybody there, move on with that suitcase to somebody else. He had never had any home. He would just travel with all his possessions in this suitcase. So Erdos wrote so many number theory papers, and number theory is sort of a pure mathematics, and so enough people, then other mathematicians wrote papers with people who wrote papers with erdos, that you could talk about erdos number for mathematicians and computer scientists who are wannabe mathematicians, right? And so it turns out that you can talk about erdos number. It turns out there are about 1500 papers Erdos himself wrote. Erdos has erdos number 0. Anybody who wrote a paper with erdos has erdos number 1. Anybody who wrote a paper with erdos, or somebody who wrote a paper with erdos has erdos number 2, and so on. It turns out that the average length for practicing mathematicians is 4.65. How many of you have not written any papers? Any. Your erdos number is infinity. Just as my Bacon number is infinity, right? Because if you don't write a paper, you can't have erdos number. And it turns out among all the practicing mathematicians, the surprising thing, the largest distance between erdos and any mathematician who ever wrote a paper in his life or her life is 13. The total number of mathematicians is what? 13? 130? No, it's much larger than that. So in fact, the distance between mathematicians and erdos seems to be logarithmic in the size of the number of mathematicians. Just as Kevin Bacon came, you are surprised that Amitabh Bachchan is connected to Kevin Bacon in 4 or 3 steps. You should also be surprised that mathematicians are connected to Kevin Bacon in only about 13 links maximum. Okay? It turns out this is my Kevin Bacon. You can actually, my erdos number. Just as you have a Bacon oracle, you have a math side people who have an erdos number thing. In fact, it's a collaborative distance computation. And so I just give myself, ask my erdos number, and then I find that I'm actually, what? My erdos number is 4. Because I wrote a paper with Dana Now wrote a paper with George Markowski, who then wrote a paper with Daniel Kleitman, who wrote the paper with the great man himself. Okay? So I'm a pretty good mathematician, it turns out. And so I also wanted to, since this one actually gives collaborative distance from between any 2 people, it doesn't have to be erdos. Okay? So I just said, let me find out how close I am to Alan Turing, who is, in our local circles, is more interesting than, erdos. And if you don't know Alan Turing, you should quickly change your major. Okay? It turns out that my distance to Alan Turing is 7, which actually shows that I'm more of a mathematician than a computer scientist. I didn't realize that. Okay? The more interesting point about this whole discussion is collaborative distances among scientists and mathematicians seems to satisfy small world phenomena. Collaborative distances between actors seem to satisfy small world phenomena. Is this a coincidence, or is there a flying spaghetti monster who is making people write papers together? So when we come back next class, we will talk about essentially random network models and talk about under what condition random networks will have small world phenomena, and then talk about power law networks and then move on. Thank you.